section, we're going to look at equivalent statements and DeMorgan's laws. Equivalent statements are statements that mean the same thing. First one we're going to look at is that P implies Q. Is the same thing as not P or Q. This is one you want to learn, memorize, because you will use it over and over in these arguments. We want to make sure we look at the positions here and not the letters. P implies Q means a simple statement implies another simple statement is the same as saying the opposite of the first statement or the second statement. It might be helpful to write it right underneath of it. And P or Q. The P turns to its opposite, the implication to an or, and the Q stays the same. So, for example, if I had not P implies not Q, that would be the same as, let's change the P to its opposite, P or not Q. Let's say we had not S implies P. That would be the same as, let's choose the opposite of the first one, S or P. So we're looking at the position. Two statements are equivalent if they have the exact same truth table. So you can make a truth table for both of these statements and they will be the same. Their truth tables, and I need one R, their truth tables are the same. If I were to do these next two, their truth tables are the same as each other, and these two, their truth tables are the same. So we're going to be able to rewrite statements in this way. Okay, the other thing we're going to use is called DeMorgan's laws. And they have to do with negation. The negation of P or Q is not P and not Q. The other DeMorgan law is the opposite of the negation of P and Q. It's equivalent to not P or not Q. Basically, you can think of DeMorgan's as sort of a distributing of the knots. Not exactly that, but it helps you to get the order right. So each piece is turning to the other one. The letters to their opposites, the or and the and, to the other one. So P turns to not P, or to and Q to not Q, and the not is used in the process of doing that. So for example, if we had not P or S, what would it be equivalent to? The not P would become P, or becomes and the S becomes not S. Suppose we had, as a different example, not Q or not P. Okay, the not is going to turn this into a not Q, the or becomes and, the not P becomes P. So each thing changes to its opposite. Now let's combine the idea of the implication and DeMorgan's law and see if we can rewrite a statement such as this. P or not Q implies S, or the other way of saying it is, if P or not Q, then S. Okay, we saw above that the first thing, the thing before the implication turns to its opposite. So this whole thing is turning to its opposite. The if-then, or the arrow, turned to an or, and the S stayed the same. Now DeMorgan's law comes into play here because we have this not in front of a parenthesis. So each of these things in the parenthesis is going to turn to its opposite. The P is going to become the not P. The or is going to become the and the not Q becomes the Q. This is a string of equivalences, so all three of these statements are the same. All three statements are equivalent. Let's do another example. Let's say we have not P and not S implies not P or Q. Okay, we have an implication. So here's the implication. This entire thing is the thing before the implication. This is the thing after. Remember, if P implies Q, becomes not P or Q. In other words, the first thing becomes its opposite. So the opposite would be two nots. Well, what does not mean? Not means it is. So you take away the not. The implication, or the arrow, becomes an or, and here we have not P or Q. So we have rewritten this one. Okay. So that's the idea of DeMorgan's law. Let's try a sentence. Mary loves chocolate and hates vanilla. Okay, what would the opposite be? Well, here we have Mary loves chocolate. So let's make that P, and hates vanilla. So that's Q. And what would DeMorgan's law tell us the opposite would be? The opposite of P and Q would be not P or not Q. So the opposite of this Mary loves chocolate and hates vanilla is Mary does not love chocolate or does not hate vanilla. You notice the opposite of love isn't hate, because just because you don't love chocolate doesn't mean you hate it, or just because you don't hate vanilla doesn't mean you love it. Okay, so let's do another example of this. If it rains or it snows, then the laundry gets wet. Okay, and we want to say the opposite. Well, let's see what's the equivalent first, and then we'll say the opposite. And what's the negation, or the opposite? Okay. Well, let's pick a letter for this. It rains. Let's make that P. It snows. We'll make that Q. the laundry gets wet, make that are. So our original is if it rains or snows, then the laundry gets wet. P or Q implies are. Remember, because of the order of preference, P or Q are first. So how can we rewrite this? Remember, the first thing, and this is the first thing, turns to its opposite, P or Q. The arrow turns to an or, and the second thing stays the same. So the first turns to its opposite, the arrow turns to an or, and the second one stays the same. Okay, now using De Morgan's law, that's going to become not P and not Q or R. So what would that be in English? It does not rain and it does not snow. Remember, the parentheses indicate a comma, or the laundry gets wet. So that's the same statement. Okay, let's try and do the opposite. If I did the opposite of this, not P, not Q, or R, each thing in here turns to its opposite. So this is going to turn to its opposite, and this and that. So I'm going to get not P and not Q, and not R. But what's the opposite here? I'm going to use De Morgan's law because there's a parenthesis. So I'm going to get P or Q and not R. So in English, we would say it rains or it snows, with the comma because of the parentheses, and the laundry does not get wet. Sometimes in English, if we're surprised by something, we use a different word for and. We use the word but. So and just, but is just and with a little bit of surprise. It rains or it snows, but the laundry does not get wet. So it's the same thing as the and. So you can use the fact of the if-then being equivalent to the opposite of the first one or the second one, and De Morgan's laws to rewrite many of these statements.